Today we'll evaluate the infinite series sum of n times e to the negative n squared from n equals 1 to infinity. Let's break this down step by step. First, let's check if this series converges. We can use the ratio test. Let's call our nth term a underscore equals n times e to the negative n squared. For the ratio test, we look at the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. Let's substitute our terms. Let's simplify this expression. The e terms can be combined using the properties of exponents. We get n plus 1 over n times e to the negative quantity n plus 1 squared plus n squared. As n approaches infinity, 1 plus 1 over n approaches 1, while e to the negative 2n plus 1 approaches 0 very rapidly. Therefore, the limit equals 0, which is less than 1, so the series converges absolutely. Let's visualize how quickly the terms of the series decrease. Here's a plot of the first few terms of the series. Since we've established convergence, let's approximate the sum numerically. The first few terms are, term 1 is about 0.37, term 2 is about 0.14, term 3 is about 0.03, and the terms quickly approach 0. Using numerical methods, we can approximate that the sum of this infinite series is approximately 0.544. In conclusion, we've shown that this series converges using the ratio test, visualized its rapid convergence, and found its approximate sum. The key insights were using the ratio test for convergence and recognizing the rapid decay of the terms due to the negative n squared in the exponent